this was very useful when we were calculating the cumulative distribution function, which is something we need in order to obtain the arithmetic code. Now, up here, it would be nice to have something similar. The advantage of this is that when we're obtaining the cumulative distribution function, we don't need to recalculate from scratch in order to get each term in the CDF. What we can do is we can use previous terms and simply append them with whatever element was the next value in the sequence. So up here, it turns out we can do something similar. The idea is this: we're going to break this down into q of x1, x2, and so on, up to xn plus 1 is equal to some q of x1, x2, and so on up to xn times q of xn plus 1 given x1, x2, and so on up to xn. So this breakdown works for any source, or excuse me, any probability density function. This is simply the definition of conditional probability, that I can always write a joint probability as a conditional probability. So, for instance, I can always write probability of A and B as probability of A given B, and probability of B. So that's essentially what I've done here. I've written probability of this vector from 1 to n plus 1 as its final element, given everything up to there, times this probability. Now, let's rearrange that. This is the critical term that I want, because this is this gives me the recursion. So basically what I'm going to end up with is q of x1, q of x1 times q of x2 given x1, q of x1, q of x2 given x1, q of x3 given x1, x2, and so on. So here I take that and put it here, take this and put it there, I'll then take this, put it down here, times q x4 given x1, x2, x3, and so on and so on and so on. So this is the term that I'm really interested in. This gives me this way to straightforwardly extend the probability. So if this has a simple form, then I can calculate any of these probabilities in a simple form. Now, q xn plus 1 given x1, x2, up to xn. What I'm going to do is I'm going to rearrange this so that this is on the left, and then I take this and divide it by that, put that on the right, q x1, x2, up to xn plus 1, divided by q x1, x2, and so on up to xn. Again, that's, if you look at this representation, that's also typical of conditional probability. Probability of A given B is equal to probability of A and B divided by probability of B. Now, what do we know about these probabilities? Well, we know that q of x1, x2, and so on up to xn plus 1 is equal to 1 over, excuse me, let me start with the denominator. Q of x1, x2 up to xn is equal to 1 over n plus 1 times 1 over n choose k, where k is the number of ones in the sequence. And so therefore, so let's call this k, kn, for the number of ones in the first n elements in the sequence. q of x1, x2, and so on up to xn plus 1, therefore, is equal to, basically, I just substitute everywhere here from n to n plus 1. So this is 1 over n plus 2, 1 over n plus 1, choose k, but now this is k n plus 1. So that's the number of ones in the first n plus 1 elements of the sequence. Now, what's the relationship between kn plus 1 and kn?
Kn plus 1.
Yeah, so
The kn.
kn plus 1 is at, kn plus 1 minus kn is less than or equal to 1. And so obviously, if I count the number of ones up to xn, and then I have the same vector, but I add another bit to it, that extra bit gives me at most one extra one. What I want is some certainty here. So what I'm actually going to do is I'm going to say, what's q of, let me do this up a little higher. What's q of xn plus 1 equals 1, given x1, x2, and so on up to xn. So xn plus 1 has two possibilities. It's either 1 or 0. So what I can do is I can evaluate them separately. Let's first do this. Q xn plus 1 equals 1, given x1, x2, and so on up to xn. So now, what's the relationship between kn plus 1 and kn? If I enforce that xn plus 1 is equal to 1, then clearly kn plus 1 must be equal to kn plus 1. I've enforced that this is a 1, so therefore there's exactly one more 1 in this sequence than in this sequence. Okay, so this is equal to, I put this guy in the numerator, this guy in the denominator. So 1 over this is n plus 1. 1 over this is n choose kn. Okay, let's start expanding. Now, I covered this last time, but I did it in an awkward way that'll make things difficult later, so let's just go back over it. Also, it's been 5 days, so good to remind ourselves. So, n plus 1, choose kn plus 1, is equal to n plus 1 factorial divided by kn plus 1 factorial times n plus 1 minus kn plus 1 factorial, but n plus 1 minus kn plus 1 is just n minus kn factorial. And so 1 over that is kn plus 1 factorial, n minus kn factorial, divided by n plus 1 factorial. N choose kn is n factorial divided by kn factorial times n minus kn factorial. So if I substitute in up here, what I end up with is